All right, so today I am going through section 3.3, which is polynomial and synthetic division. It's really important to be able to work through this week's material in this particular section because you're going to be using synthetic division in every section essentially that follows this. You'll be using it a lot, so it's really important to get an idea of how to do this and what everything means, especially because we do have a lot of vocabulary and definitions in this section. So 3.3 covers using long division to divide polynomials by other polynomials. And it covers using synthetic division to divide polynomials by binomials of the form x minus k, and using the remainder theorem and the factor theorem. So I'm going to start with long division of polynomials. Fun fact, when I was in high school and I had to wait around at doctor's offices, I would just make up long division of polynomial problems to keep me occupied. I don't know why, because that was when I still felt like I didn't like math, but for some reason I really enjoyed doing those types of problems. So probably should have paid attention to that because that would explain why I'm in math now. Anyway, so long division of polynomials is similar to regular long division. So I'm going to do it side by side so you can see that the algorithm is essentially the same. So first I'm going to do 435 divided by 3. So I'm going to set it up. And so now 3 goes into 4 one time, and then 3 times 1 is 3. I subtract, 4 minus 3 is 1, and then I drop down the next number. 3 goes into 13 4 times, 3 times 4 is 12. Subtract, get 1, drop down the next number. 3 goes into 15 5 times. 3 times 5 is 15. Subtract, no remainder. So our answer is 145. So now let's see that same process, but with variables. So I'm going to set this up 4x squared plus 3x plus 5, and then 3x minus 1. So you can see the setup is similar. Now when we do long division of polynomials, we always look at the beginning of what we're dividing by. So we have 3x. So 3x times what gets me 4x squared? Or basically, how many times does 3x go into 4x squared? I should have put a different number here. This is going to give me fractions. I didn't really consider that. So to get, you know what, I'm going to just make this, instead of 3x, we'll just go with it. No, I'll make it easier. Let's put this 3x squared just so I don't have to deal with fractions. I was trying to make a polynomial that was similar to 435. Didn't really think about it. I'm going to get fractions. So 3x times what gets me 3x squared? Well, that is times x. 3x times x is 3x squared. I also multiply negative 1 by x, so that's minus 1x. So now I subtract 3x squared minus 3x squared is 0. And when you're subtracting a negative, that turns into a positive. 3x plus x is 4x, and then plus 5. Oh, I'm going to get a fraction again. I should have worked out this example before rather than just trying to make it up. This is not working out nicely for me. If I change that 3 to a 5, 5 plus 1 is 6. Okay. I'm trying to make it so it works out nicely. Okay, so 3x times what is 6x? That's 2, so it's plus 2. 3x times 2 is 6x. And then I multiply the negative 1 times 2, so that's negative 2. And then I subtract. And when we're subtracting a negative, that turns into a positive. 6x minus 6x is 0. 5 plus 2 is 7. And then that's a remainder. So our answer would be x plus 2. And then just like when we had remainders of division, you make it like a fraction. So we're still asking the same question. What times what gives me this? Then you still subtract. and then you bring down the next term. So the algorithm is the same. It just looks different because we're now using variables, and it actually doesn't come out nicely a lot because you have to deal with fractions, and it's very hard to make a problem up and have it work out nicely. So why do you need to know this? So if you know something is a factor of a polynomial, then you can do division by dividing out that factor to get the rest of the factors. Because factors are things that multiply to something else. So you wouldn't undo it, you divide to get the other factors. Long division is also helpful next week when we're looking at rational functions. So specific tasks that need long division of polynomials are factoring polynomials of degree 3 or higher. If it's degree 2, you can use the quadratic formula, or just factor by guessing and checking, any other method. You need to do it to find oblique asymptotes, which is something that we'll do next week. And then you can also use it for simplifying rational expressions, which is something that you often need to do when you're in calculus. A lot of these skills, the factoring, is also helpful in calculus. So if you're going on in calculus, understanding how to do long division of polynomials is going to be helpful for you. So what I did is basically called the division algorithm. If f and d are polynomials, such as that d does not equal 0, and the degree of d is less than or equal to the degree of f. So, and I've written this basically separately in black on the bottom, f over d, d is the denominator, what you're dividing by. Then there exists unique polynomials q and r such that d times q plus r will give you back your original. Or the way that we run it when we did the division is that q is the quotient, basically what divided evenly, and then you have a remainder, r, that you write over fraction over what you divided by. So the more useful way that we write this is like how I did my example. I would not focus so much on what the division algorithm and what it, like, I would focus more on the vocabulary that goes with the division algorithm, the divisor, the quotient, the remainder, and also on how you write things that you divide, which is what I have here in the black box. That's what you need to take away from the division algorithm. So here's an example. So I'm going to do this one slowly, and I'm going to show you all the side work that I did on my head on the other example that I was just demonstrating that the process is the same. So here I'm going to show you all the stuff that you would do to write this out, the side work, and then how you'd write your answer. So we have 5x cubed minus 6x squared plus 3x, and we're dividing it by x minus 1. So I need to set this up. And now the key with when you're dividing things with polynomials is you have to make sure you have all of your terms. So if you're missing anything, you have to add a 0 there. You need that placeholder because that actually matters when it comes to determining the remainder and for lining everything up. So because I didn't have a constant term, I needed to add that in. And then I'm dividing this by x minus 1. Now, we always look at the beginning of each polynomial when we're looking for the division. So you're asking yourself, x times what gives me 5x cubed? The other way to look at this is to do the division. Oops, I meant to have that as a pen. 5x cubed divided by x gives me what? So this method kind of helps you determine what you're multiplying by without having to sort of think mentally about it. It's a little more routine because you're just following the rules of exponents. So you have 5, and then you are removing an x, so you get 5x squared. So that is what gets written up on top here. Now you take 5x squared and you're going to multiply it by x minus 1. So 5x squared times x minus 1. And so that gives me 5x cubed minus 5x squared. So that is what gets written underneath, and you have to make sure your terms line up. So now we're subtracting here, and so when you're subtracting a negative, that turns into a positive. So I like to put a little plus sign there to make sure I remembered that I changed that. That was a minus 5x squared, but we're subtracting, so now it turns a plus. There's a little rhyme. You can say, draw the line, change the signs, and combine, because that will help you remember that you're subtracting and you have to pay attention to negatives becoming positives and so forth. So 5x cubed minus 5x cubed is 0. And then minus 6x squared plus 5x squared, that gives me negative x squared. And now I drop down my next term, the plus 3x. So now I'm going to follow the same process. Oops. And now I'm going to look at the negative x squared. So, I keep accidentally changing my highlighter when I mean to change my pen. So I'm going to look at it as division. I have negative x squared. I'm dividing it by that x. That gives me negative x. When you subtract the exponents, x squared over x, you're left with an x. So that is what goes on top for the next line, minus x. And then I take that minus x and I'm multiplying it by x minus 1. And then I'm going to distribute. That gives me negative x squared plus x. So that's what I write underneath. Then you draw the line and change the signs. And then you combine. Negative x squared plus x squared is 0. 3x minus x is 2x. And now I need to drop down that 0. Now I'm going to look at the first term again, the 2x. So 2x divided by x gives me 2. So I'm going to write plus 2. Now I take that 2 and I multiply by the x minus 1. So when you distribute, you get 2x minus 2. So I write that underneath. I draw my line. I change the signs. And I combine. 2x minus 2x is 0. 0 plus 2 is 2. And 2 is the remainder, because if I took 2 over x, that does not simplify. So that's how you know it's a remainder. So our answer, when we write this, is 5x squared minus x plus 2 plus 2 over x minus 1. So your remainder needs to be written over what you're dividing by, the x minus 1. So because we have a remainder, this does not divide evenly. And if it does not divide evenly, that means that x minus 1 is not a factor. If it was a factor, it would divide out nicely. So here's another example. Knowing that x squared plus 1 is a factor of x cubed plus 5x squared plus x plus 5, factor the polynomial. So if x squared plus 1 is a factor, that means when we divide, there will be no remainder. And the answer of the division will be the other factor. So I'm going to set up the division. X cubed plus 5x squared plus x plus 5. And I'm dividing by x squared plus 1. And so I'm always going to be looking at squared and then the first term of the polynomial. So I have x cubed, take the inside, divided by x squared. 3 minus 2 is 1, so I have an x. So that's what gets written on top. because x squared times x will get me x cubed. And then I take that x and I multiply it by x squared plus 1. That gives us x cubed plus x. So I write that x cubed, and I have to line it up correctly. So be very careful about that. And now we draw the line, change the signs, and then combine. X cubed minus x cubed is 0. 5x squared plus 0 is 5x squared. X minus x is 0. So I have nothing there, and then I can drop down the plus 5 if I want. Now we're going to repeat the same process. This time I'm going to look at my 5x squared. So x squared times what gives me 5x squared? And that's going to be 5, and you can verify that by doing the opposite. 5x squared divided by x squared, that is 5. So I write plus 5. Now I take that 5 and I have to multiply it by the x squared plus 1. This gives me 5x squared plus 5. So I'm going to write that underneath. And I draw the line, change the signs, and combine. 5x squared minus 5x squared is 0. 5 minus 5 is 0. And I have 0, which means there's no remainder. And that is how it should be, because if it's a factor, you get no remainder. So that means when we divided, we got x plus 5. And that means x plus 5 is the other factor. So factoring the polynomial, one of the factors is x squared plus 1. The other one is x plus 5, the result of the division. So this is a polynomial cubic. We could factor this one by grouping. You can also factor it if you know what one of the factors is already going to be. So now moving on to synthetic division. So synthetic division, I would say, is the preferred method for doing any kind of division, but it only works when you have things that are in a certain form. When you're dividing by something that is x plus or minus a number. So there are some cases where you cannot use synthetic division, which is why you need to know long division. But most of the time, synthetic division is perfectly fine and works, and it's faster. It's easier for people, so I recommend using it whenever possible. So this is a picture from the book where they're trying to explain synthetic division. And it has this pattern, and the vertical pattern is adding, the diagonal pattern you're multiplying by k. It's a little confusing. I think it's better to actually see it worked out. So we want to divide 4x cubed minus 15x squared plus 11x minus 10 by x minus 3. Now I set mine up a little differently than the book does. The book sets it up like this. Some books will set it up like this. I set it up like this. So there are different ways. It depends on which book you're seeing. I set it up as the bottom one because that's easier to put it in Word if you're typing your work, because you can do a table. Plus, if we're trying to guess at factors and try to figure out what divides evenly, I can just keep making new rows and not have to rewrite it. So that's why I do it that way. But the book shows it with the line underneath. Other books make it look like division. So it's really up to you. But I'm going to show it my way. So the whole way this works is you take the coefficients. You ignore the variables. You're looking at just the coefficients. So in the numerator, I have 4, negative 15, 11, and negative 10. So those are the coefficients of the numerator. Now, when we're dividing by x minus 3. So you say, what number makes my denominator 0? That would be 3. 3 minus 3 is 0. So 3 is the number that I use as that I'm going to be dividing by. So this is what makes the denominator 0. So another way, because we're always dividing by x plus or minus a thing, it's always the opposite sign of whatever you're dividing by. So if you have x minus 3, you're going to use plus 3. Now, the first spot is always going to be the same as what's above it. So this is always the first coefficient dropped down. And now you have it set up. From here, all we do is multiplication and division. So I multiply 3 times 4, which is 12, and I put that on top of the next number. 12 minus 15 is negative 3. Then you take that 3 and you multiply it by the negative 3. That's negative 9. Negative 9 plus 11 is 2. Then I do 3 times 2, which is 6. 6 minus 10 is negative 4. That last number is a remainder. So if you don't get 0 in the end, that is a remainder. So now I've just gotten a series of numbers, and the question might be, well, what are those? What does that mean? So I'm trying to think what color I want. So we started with something that was x cubed. So when you're dividing, you're losing a power, so that becomes x squared. And then you just count down from there. So that's 4x squared minus 3x plus 2, and then a remainder. So my answer is going to be 4x squared minus 3x plus 2 minus 4 over, and then I divide it by x minus 3. So it's giving you the coefficients of your answer. And your answer is always going to be 1 degree less than what you started with. So if you started with something that was degree 3, you're going to end up with a degree 2. So the remainder theorem is basically just saying that if you're dividing by something, then the remainder, that last thing, is also the same as the function value. This is really neat. So if I set up my synthetic division, and whatever my number is in that lower left corner, and then let's say A, B, C, D, whatever the number is here, that remainder, that is the same as if I plugged k into the original polynomial. So it actually gives me function values. So you can use synthetic division to evaluate a polynomial. And it's actually faster to do it this way than to actually use your calculator and do all the exponents. So here's an example of how this works. If f of x is negative 3x to the fourth plus 15x cubed minus 50x plus 25, use the remainder theorem to find f of 4. So this means I want to know what is the answer if I plug 4 into f of x. If I plug that in as it is, I'm going to have these big exponents. I definitely need a calculator. But let's show you how you can do this without needing a calculator, and that's with using synthetic division. Or you may need a calculator, but not as much as, you can do most of it in your head. So I'm going to set up my synthetic division with the coefficients of my f of x. So I have negative 3, 15. Now note I don't have an x squared term, so that's going to be a 0, then negative 50, then 5. So just like the long division, you put zeros if you're missing a term. So there was no x squared, so I have to put a 0 there. Otherwise, this is not going to work out. 4 is what I want. So this would be the same as dividing by x minus 4. If they're giving us f of something, then that's just what you use, 4. And then I'm going to drop down my -3. And so now all I'm doing is multiplying and adding. So I do 4 times -3, which is -12. -12 plus 15. 15 minus 12, that's 3. Then I do 4 times 3, which is 12. 12 plus 0 is 12. 4 times 12 is, let's see, 4 times 8, so that's going to be 48. 48 minus 50, -2. 4 times -2 is -8. 25 minus 8 is 17. So I just did all of that in my head, because I know my multiplication, and the final answer is 17. So f, let me change that color. F of 4 is equal to 17. And we can verify this. So we can evaluate this by plugging in and using our calculator. So first I have to write it all out and plug in the numbers in the right spot. And now 4 squared is 16, and 16 times the -3 is a -48. 4 to the 4th power, 4 to the 3rd power, 64 times 15, that's 960. Definitely not something I can do in my head. 50 times 4 is 2. Whoops, I typed in 60, but it should give me 300. Okay. Nope, I did 50 times 6. It should be 200. Double checking my calculator. Yeah, so that's minus 200. And then plus 25. -48 plus 960 minus 200 plus 25. -48 plus 960 minus 200 plus 25. Did I do my math wrong? I got 737. Oh, because I did 4 to the 2nd squared instead of 4 to the 4th. Okay, I'm like, I know this is supposed to match. 4 to the 4th power is much bigger. 256 times -3. Okay, -768. Now, let's add these. Okay, this comes out to 17 like it's supposed to. So, you can see, I was able to get 17 without making a mistake by using synthetic division, but when I tried to find it with our normal method by evaluating and plug it in, doing exponents, I made a mistake and I didn't get the right answer. And you end up with much bigger numbers. It's a lot harder to figure out what's going on. So this is what the remainder theorem means, basically, is that you can find the value of a polynomial by using synthetic division. Now there's also something called the factor theorem. So if the remainder after division is 0, which means there's no remainder, then that means what we've divided by is a factor. So I talked about this before. If the function value is 0, then that x value is a 0. So things that are factors are also zeros of a polynomial. So we have found zeros of polynomials or x-intercepts by factoring and setting them equal to 0. So if things are factors, then that means that also gives us zeros. So I've got a couple examples here. First is k equal to a 0 of the following polynomial? So if it's a 0, if I plug it in, then I should get 0 for a remainder. That's what it means to be a 0. So I'm going to evaluate it using synthetic division. So my first coefficient is 2. The next one is -3. I don't have an x term, so I need a 0. And then -18. And then I use 2. So the only time I change the sign is if we're actually dividing. Here I'm not dividing, I'm finding function values, the sign does not change. And then the 2 drops down. So now I multiply, 2 times 2 is 4, 4 minus 3 is 1. 2 times 1 is 2, 2 plus 0 is 2. 2 times 2 is 4, 4 minus 18 is negative 14. Because I got a remainder, it is not a 0. Because what we just found was that f of 2 is negative 14. The definition of a 0 is that it equals 0. So the answer is not a 0, because it did not have a remainder of 0. Here's another one. Given that x equals negative 6 is a 0 of f of x equals x cubed minus 52x minus 96, factor the polynomial. So here's how we're going to use knowing zeros to factor. So I'm going to use synthetic division. So I'm going to set it up. So x cubed has a coefficient of 1. I don't have an x squared term, so that's going to be 0. Then I have negative 52 and negative 96. Now if x equals negative 6 is a 0, if they're giving us the x value, then we use the same thing. So that's negative 6. So I'm going to put negative 6 there and drop the 1 down. And just as a side note, that means the factor is x plus 6. So we're factoring, we're looking at, we know that the 0 is negative 6, which makes the factor x plus 6. So that's one of our factors. So now I'm going to go through the synthetic division. I'm going to multiply. Negative 6 times 1 is negative 6. And then add. Negative 6 plus 0 is negative 6. Negative 6 times negative 6 is 36. 36 minus 52. That is one where I'm going to use my calculator. And make sure I actually enter it in correctly. That gives me negative 16. Negative 6 times negative 16, definitely using a calculator for this one. 96. 96 minus 96 is 0. So we got a 0. X equals negative 6 is a 0, so that's why we got 0 at the end. If we didn't, then that would mean it's not a 0 and they lied to us, or we made a mistake. So we divided. We know one of our factors is x plus 6, so I'm going to write that up here. And now let's take a look at what we have left over. So we started with something that was x cubed, which means that I now have an x squared, and I can put in my variables. So now we have x squared minus 6x minus 16. Now we have a quadratic, so now we can factor this. So I know this is going to be x times x. I need two numbers that multiply to negative 16 and add to negative 6. That's going to be negative 8 plus 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. And so those are the other factors. And so our answer, our factored polynomial, is x plus 6, which was given from the 0, and then x minus 8, x plus 2. And now we have factored that entire polynomial. So that is synthetic division. It's used for a lot of things. You may have to watch this session multiple times for it to sort of sink in. 3.4, you're going to be using this a lot because we're going to be doing a lot of factoring, and you definitely need to do this on the assignment. So definitely take your time to learn this. Watch this multiple times if you need to. Sunday, I'm going to have a session at noon on zeros of polynomials. That's going to be on 3.4. And that is where I'm essentially going to be walking through most of the assignment. So make sure you're there, that you can watch that, or if you can't make it, you watch the recording. So if you have any questions, you can give me a call, you can email me, send me a chat message, and hopefully I'll see you guys on Sunday.